We welcome you to Glass Academy Webinars 2022-23. The theme for this year is Ideas in Architecture, Innovation, Design Thinking, Emerging Trends Around the World, and Sensibility. Today we have with us architect Rahul Grover. Approaching sustainability in the built environment has always been a core value to Rahul. Coming from an architecture background and a specialization in building physics, Rahul uses integrated approach to achieve sustainability in projects. Having started his career in 2016 in architecture and engineering firms, he is committed to contributing towards the global energy and carbon emission goals. He has 4 years of experience working in Netherlands and India, allowing him to have a wider understanding of sustainable construction techniques. Rahul is a senior building physics engineer at Ar.Rahul and is involved in bringing down the operational and embodied carbon emissions of buildings while improving thermal and visual comfort inside occupied areas. He uses his knowledge and experience of parametric tools and building simulation to deliver high performance and net zero buildings. Welcome. We are delighted to have you here with us and we are looking forward to your presentation. Let's hear from you over the topic, emerging importance of sustainability around the world. Over to you, Architect Rahul.
Thanks, Kanchan. Also, thanks for the great introduction. And I think what we have missed is I'm currently working in UK as well since past 1 year. So I have 1 more year of experience where my experience was highlighted. My current role, as you said, is Senior Building Physics Engineer at Ar.Rahul. And what we will be covering today is mostly not the design principles or the net zero design strategies around the architecture, but more how countries are moving towards the net zero goal. But feel free to also ask any questions around the building physics because that's my role and my day-to-day job. So I can answer those questions. About Ar.Rahul, we are a company of almost 2,000 engineers and professionals working in the built environment around the whole world. And we have around 30 offices situated all across the world, mostly in the UK, some in the Saudi areas, and a lot in US as well. We provide consultancy in all kind of disciplines, which are airport planning, acoustics, structural, sustainability, deep engineering, and more that you can see on the screen. We are working in different sectors as well, which span from airports and commercial, cultural buildings, education, science and technology, entertainments, and urban development. We've been working with very different kinds of clients as well. So they can be architects or Google or Microsoft, as you can see on the screen. We also provide consultancy to the government around the world, sometimes mostly in UK and more. My personal journey in sustainability has been, as you have also mentioned, that I had a bachelor in architecture background from SPA Delhi. And then I also worked as an architect for a few years in India as in morphogenesis, after which I decided to focus more on the building physics side of things. So I decided to take my master's in building technology at the UDEF, Netherlands. And I kept practicing after that as building physics engineer in 2 companies, Fizzy and ABT. And now I'm at Ar.Rahul as a senior building physics engineer. But we are here to talk about one of the biggest challenges that the Earth is facing right now. That's climate change. And since 1950, we have witnessed what the Worldwide Fund has termed the Great Acceleration, and a great acceleration of socio-economic trends and of Earth system trends. The rapid and immense social, economic, and ecological change this has spurred shows us that we are in a period of great upheaval. Some of these changes have been positive, some negative, and all of them are very interconnected to each other. What is increasingly clear is that human development and well-being are reliant on healthy natural systems, and we cannot continue to enjoy the former without the latter. Since 1900, the increase in temperature has been widespread across the world, but has varied in magnitude and timing depending on the region. Some countries, particularly those in the northern hemisphere, have seen more significant increases in temperature compared to the others. Countries in the Arctic, such as Alaska or Russia, have also experienced the highest increase in temperature, with some areas seeing increases of almost 4 to 5 degrees since 1900. And this warming trend has led to rapid melting of glaciers and sea ice and more. The challenges ahead in addressing climate changes are significant. We need to reduce our carbon emissions, adapt to the change that are already happening, and ensure that everyone, especially the most vulnerable, are protected from the impacts of climate change. We also need to ensure that this transition to the low carbon economy is fair and just, and that everyone has access to the benefits of this transition. The Paris Agreement that has been adopted in 2015 set a goal of limiting global warming to well below 2 degrees Celsius above pre-industrial levels, with an aspiration to limit the warming by 1.5 degrees. This is because even small increase in temperature can have significant impacts on people and the environment. For example, a 1.5 degree increase in temperature would result in more extreme heat waves, more intense storms, and more sea level rise. One of the biggest challenges we face is that the world is currently on track to exceed these targets already. And in order to avoid the worst effects of climate change, urgent and ambitious actions are needed to reduce the greenhouse gas emissions. We're also seeing these impacts firsthand. The impacts of global warming are widespread and far-reaching. So some of the most notable impacts that we're seeing already are the fires in Australia, rising sea levels, changes in precipitation patterns, and increased frequency of heat waves, shifting ecosystems and more. We're seeing an increased awareness in and concern about the impacts of climate change on people and the planet. People are also becoming more aware of the economic costs of climate change and the benefits of taking action to reduce the emissions. So from school strikes to protests to campaigns, people are calling on their leaders to take action to protect the planet. We're also seeing increased political will to address the climate change. Many countries have set ambitious targets for reducing emissions and transitioning to a low carbon economy. The Paris Agreement is a good example of this, with almost every country in the world committed to take actions to address the climate change. Because we have seen overwhelming scientific evidences of rapid and profound changes happening in Earth's climate system, climate emergency has also been declared. Governments around the world are committing to net zero carbon goals, and many countries are taking steps to reduce their emissions. But what exactly are they doing about it? It's interesting because some countries are taking different approaches to address the climate change by investing in renewable energy. Some are implementing carbon pricing mechanisms, and some are setting targets for reducing their emissions. But what is important that all of the countries are working towards it to achieve the goal of Paris Agreement. Here we see that some of the countries have even included their net zero strategies in law. Some have reported them in the policy documents submitted to net zero frameworks. And what's interesting is that this graphs or this diagram keeps updating constantly. But the last time I saw it, it was quite gray, and it has only recently updated all of these colors. So which shows that a lot of countries are taking action towards it. There are many factors driving the push for the net zero carbon goals. One is increased awareness of the impacts, and which is making clear that we need to take action. And there are also the cost of renewable energy, which is making it more viable to transition to the low carbon economy. But there are also push on the clients, funders, and practitioners like us who are also driving this change. There are more drivers such as the businessmen like Satya Nadella or people from Google and other companies who are also driving this. In UK, in the built environment, the UK government has committed to achieving the zero carbon emissions by 2050. This was previously 80% reduction by 2050. they're doing it is quite interesting by making it the norm. And based on their current pathway, it can be seen that they are on track to reduce those carbon emissions. There are even policies at the borough level in London to reduce these carbon emissions and to achieve higher goals, ambitions in built environment. How are they reaching net zero is quite interesting because they're not really just reducing the carbon emissions to zero level, but they're also investing heavily in the carbon offsetting schemes, and which every building is mandatory to have at the completion. And this shows us how they plan to achieve zero by 2050. This graph is a slightly more detailed graph, the previous ones, which shows that there have been variations and constant revisions to them, which keep changing the way the buildings function. So by 2030, there is a plan to end the gas boiler systems for the provision of heating in the buildings. There are also new regulations, such as regulations on embodied carbon, like Part Z, which is to be enforced soon. And the other revisions to Part L and other documents are always underway to make them more stringent and more onerous. But is that enough? Because at one point, the clients or everyone would just want to go for the bare minimum for their buildings. That's where we're seeing the market-driven sustainability in London as well. Because the norms are just fit for all kinds of buildings in the country, because they also want to have some sustainability buffer, and clients want to do the bare minimum. But here is what we're seeing, that the real estate developers and other clients are also aiming for the targets that are in 2030, because they want the building to be lasting more and have more value. Some are also seeing that their buildings are having longer leases. They have more occupancy when their buildings are achieving higher goals, and their asset prices also increase. So where they can do the minimum, which is the London Plan, the Part L, BREEAM, and some boroughs, they are also going for BREEAM outstanding and well-enabled buildings, and they're also designing for more operational energy reductions, which are set by some guidelines by GDC, neighbors, and the more guidelines. But to answer the question, what is exactly net zero and how do they reach it? What is included in it? Is it carbon or energy, or is it embodied carbon or operational carbon, or on-site or off-site, or everything? So that's the important thing to understand, because in UK GBC, they have two definitions. There is one definition, which is net zero carbon for construction, and the other is for net zero carbon for operational energy. You can always reduce both of them and achieve a common target of net zero building as a whole. But net zero construction asks you to reduce the embodied carbon of the materials and then later just offset all of the remaining carbon. And in reducing the operational energy, you need to, on one side, reduce the operational energy and then buy on-site renewable energy, or not buy, basically just offset your renewable energy on-site, but also buy some off-site renewable energy throughout your life. And this shows a diagram that we use in Ar.Rahul, where some of them are within the scope of our Ar.Rahul's sustainability and building physics team. Some outside our team, but we can still provide consultancy on that, on how to procure the off-site renewable energy. In the zero operational energy building, or zero energy operational building, we don't just talk about the heat and the cooling energy required, or the lighting energy. What is also added into it is the equipment loads, or unregulated energy, as we say. That includes the power that we as occupants need inside the building. The lifts, the servers are not really accounted in the bare minimum compliance reports, and they can actually cost up to 50 to 60% of the overall carbon emissions. So this is where UK is doing slightly better by closing the gaps in between the client compliance reports and the other performance modeling. And by reducing this gap, we are seeing that we are able to deal with this challenge better, where we can also set the compliance standards to be more ambitious and bring them to actual reality. And how are we designing for net zero remains to be the same principles that everyone knows probably, that we need to increase the daylight, we need to increase the natural ventilation, and we need to reduce the heat loss from the facade. Some of the projects you see here would have common themes to them, that they have a lot of PV arrays. They will have a shallow building plan to allow for more daylight inside, and they would also have exposed mass or phase changing material, and they would allow for natural ventilation and have less glazing ratio. And most of these projects are done by Ar.Rahul, I believe, and they're not all located in UK. So that's why you might see some of them having higher glazing ratios as well. But at the end, I would only like to say that with all the policies, frameworks, and organizations pushing towards the goal of the net zero, our architectural sector might be on the right path now. But it will not be possible to achieve the goals without the combined effort from everyone. Architects, engineers, policymakers, and students make rapidly move to these roles are the ones who can make the biggest difference. So I would like to encourage all of us to work on the shared agenda, because right now it is already too late. Thank you.
Yeah. Thank you for showing us how working professionals can drive change in policies and how that eventually increases awareness among users and clients. It was very, very encouraging to see the importance of sustainable buildings rising in the world. I'm sure our viewers have a lot of takeaways from your presentation and must be curious to know more, myself included. And I would like to take this opportunity to ask you a few questions.
Sure.
I'd like to touch upon your history and your work experience with building physics. You have an educational background in architecture and experience in developing tools for mapping building performance. How do these tools advise your projects from both architectural as well as engineering point of view?
So yeah, that's an interesting question, because the tools that I work with are mostly important at the early design stage. And here in UK, they have the design stages numbered, which we call REBA stage 1, 2, 3. Stage 1 being the concept design stage. So where my tools, where I use them, influence the most architectural design at the concept stage. We can basically optimize the performance of the building by generating as many number of options as we can by the parametric tools to see how they perform in terms of daylight, in terms of energy, and solar heat gain inside the building. So that's where I work. And for the stages of the project, we use more advanced building simulation software such as IES to do the compliance reporting, but to also actually implement the MEP strategies that the MEP engineers are focusing on to see the actual impact. And yeah, like I said, close the gaps between the actual performance of the building. So by implementing those strategies, we can be closer to what the building would actually perform later.
You have extensively worked with aspects like the operational energy of buildings, the daylight requirements, the embodied carbon footprint, and circular economy, like you've shown us in your presentation. How do these affect your material choices, if that is any way covered within your work?
Yeah, I think material choices is something that now all different consultants are also taking into account. So facade consultants, structural consultants, they even have tools in-house in their team that they use before making those strategies or recommendations in design. Even architects have those kind of things. We sometimes come at a later stage where we are probably less helpful in terms of recommendation, but more helpful in generating the whole numbers and the life cycle carbon reports and see the life cycle impacts of those materials. But it's never too late. Obviously, if the material is not performing really well, or if the architects need suggestion at an early design stage, we can still do impacts of materials and their life cycle impact at an early design stage. So we use tools like One-Click LCA, some other tools that are built in-house in Excel to show the impacts of what materials would cost. But sometimes it's not really feasible to change, let's say, the whole structural system of the building from concrete to completely timber because of the vibrations in the building. So you need to have concrete sometimes. So that's where maybe hybrid building systems come into play, and you would not always have completely timber building.
That was a very insightful answer. And what would you say, like, how has the change in policies in Western Europe, like you have mentioned, facilitated this rising demand for sustainable buildings? Like, how big of a role has that had to play?
I think that's the most basic thing that the market needs, the policies. And only after that, the market can be pushed into that their competition of achieving higher sustainability standards. Because here in UK and especially in London, where the boroughs have their own policies, and you need to meet them, which are extremely high sometimes. And sometimes the policies have been made in such a way that some kind of buildings cannot even achieve them. So it's important to always aim for a higher and ambitious policy first. And then I think the market just keeps driving in that direction and have even more ambitious targets. And I think some other local boroughs or local real estate developers would set even higher ambitions. So that's why I would say the policies are the bare minimum and the basic thing that any city or any country needs at the moment.
So, as a follow-up to the previous question, I'd like to ask you, can we say that this demand for sustainable buildings is going to reach India soon? Like reach around the world to India soon? And what role could young professionals in the field play in this?
Again, an interesting question, because I think unlike UK, India has set their targets at 2070 instead of 2050. And they might be revising those targets. They might revise it to 2060 or 2050. But yeah, I'm pretty sure that these targets will definitely be need to be adopted by India as well. I think we are seeing some cities like Hyderabad or Bombay going closer towards these targets and setting even higher ambitious goals with 2050, I believe. And to answer the second question, I think we as professionals, although the students and architects or any engineer cannot do anything right now in the policy level, but maybe they, as they grow in their career, I think they can still be more influential. And in India, we have organizations such as Indian Institute of Architects and the IGBC. So people like us, more influential people, can always keep working with them to set these policies and more ambitious targets. I think that's where India can also reach those net zero carbon goals.
This has been a very, very wonderful and, should I say, a hopeful presentation for me personally. And I'm sure our viewers will also appreciate this. On behalf of all of us at Glass Academy and Ethos, I'd like to thank you for sharing your thoughts with us today.
Thank you so much for having me as well.